Hello students, I want to briefly talk to you about lab number 1.3. This is for CETT1305 AC circuits. Today we're going to be working with our function generator right here. And what we're going to do is we're going to connect our BNC connector right here in the main. And then we're also going to use channel 1 on my oscope right here. And we're going to connect the two leads just like we have demonstrated here. So the idea is that we're going to dial this frequency in. We're going to adjust the amplitude knob right here to get the voltage we want. We're going to measure it on the oscope. And then we're going to take the digital multimeter and calculate, or we're going to take the digital multimeter and take our readout for voltage and look at that, okay? So what we're going to do is we're hooking up these two instruments, just 1 times probe off the BNC connector for channel 1 and for our main output. Those are the two connections here. Make sure that this is set to the third one where it has sine wave. And then we're going to adjust our oscope to read this signal. And we're going to fill this chart out right here, okay? So the idea of the chart here is we're going to start out here, and my given voltage is 6 volts peak to peak. So what that means, if I have this on 1 volt per division, it's going to be 6 centimeters high. I take column 1 times column 2 equals column 3. That's 6 volts peak to peak. Now there's a formula that we haven't talked much about, and we'll go over this in class. My voltage peak to peak is multiplied by 0.707 and divided by 2, and that gives me my voltage RMS. And then that voltage RMS, which is calculated here, for column 5, we're going to take our digital multimeter and measure it when I have it set for 60 volts and 6 volts peak to peak. And then for me to look at my 6 volts hertz, remember my oscope reads time, is I have to take, calculate time, and time is going to be 1 over 60. That comes out to be 16.7 milliseconds. If I set my time-based knob, which happens to be this knob right here, to 2 milliseconds, that means if I set it for 2 milliseconds, it's going to be 8.3 centimeters wide. I'm going to measure that on my oscope, and I should measure that 8.3 times 2 milliseconds equals 16.7 or 16.6, and the reciprocal of that is what my time is, 60 hertz, which is my given value right there. So we're going to be working with this in lab. We have 6 of these. We're going to do this as a group exercise. I just wanted to show a quick video here so you have something to go back and look on, and hopefully this will make more sense as you come to class. But I wanted to give you a brief overview, and we'll see you in class next time. Take care.